It is time. All right, still 2 people short. I'll give them a minute here. Otherwise, good morning, everybody. Welcome to the second quarter. We made it. We're a fourth of the way done with this year of a thing. Jumping out. Grab a parachute on your way. Okay. All right. I still have 1 person that needs to take the test. Therefore, I'm going to save any and all comments about said test for at least tomorrow, where we'll cover details like retake corrections and makeup and all that stuff. Okay? All right? So that's coming tomorrow. Today, we take a short break from coolmath.com. Really?
Honestly, I'm not gonna lie to you. I got kind of confused. Like, I started saying the cool guy slope instead of like the actual. I don't know. Like, there's too many names.
Yeah, that's what makes it fun. See, that's why I like that site.
And then like plus X and stuff. I was like,
Yeah. No, but it's important. The reason I use that site and the reason you should think that way is because you need to be able to categorize these things. Right? When he says, oh, X and stuff, it's not being dismissive. It's trying to get you to think about the equation in a certain way. It's not that the and stuff is not important. It's that all of that can be chunked together and treated as one thing that plays a particular role separate from the other terms, right? And so that's what he's trying to get you to do, okay? That's one of the reasons I like that site. And also, he summarizes and condenses, here's just the basics of what you really need to know. I think it does a really good job of that. Trust me, if we were using some textbook, I've looked at the PreCalc textbooks out there, they're a nightmare, really. There's way more stuff. It would be a much longer list that we would be trying to tackle this year if we were using a standard textbook to base our stuff on. However, there is one gap that I noticed in the list from Cool Math, and that is in actually solving polynomial equations. It doesn't spend as much time on that. So I thought we would spend these next 2 weeks focusing on those aspects because it will be a big deal when we get to calculus. And I will tell you why here in a moment. Okay? Polynomials are super common. You can model just about anything as a polynomial, right? In fact, why don't we take like half a second. Please ignore my looking up Pokemon cheats. And just to give you an idea here, right? Just about any data. Ooh, look at this, right? You run an experiment scientifically, or you collect some data about the performance of your company, analytics, right? Whatever. Data. The top thing in the world right now, analyzing data. And you try to fit a graph to it.
that's a constellation.
I know, right? Like, this is the most scattered of scatter plots. There's no general trend. You can't fit this to a single line. It's not a straight line. It's barely even a single curve, right? At best, we can approximate this, although they've got kind of sharp edges here, so this is probably not an actual polynomial drawn on here. But a polynomial could fit that data. All you have to do is go out to, the 17th power or whatever it takes to fit that, right? Here's another one. Look at the difference here between a low power polynomial here in orange. That's a nice smooth curve versus the higher power polynomial that adds additional wiggles and loops along the path to try to fit to the specific data better, right? So polynomials are a big deal because they can be applied to pretty much anything, which means your time in calculus is going to be spent with a lot of polynomials. And when you do the calculus on a polynomial, you'll be left with another polynomial. It's actually kind of fun. We'll see that at the end of the year. It turns out the answer to the derivative of a polynomial is another polynomial. Slightly smaller, though. It does get better. But you're still left with that type of a function. And if you want to solve it, you will have to use the number one, possibly most important skill whenever you get stuck in math for the rest of your life is factoring. When in doubt, factor it out. That's what I always say. And so, today I get to introduce you to, well, possibly my favorite lectures, the 7 rules of factoring. So, we're going to have sort of an abbreviated combination here from, I'm just reusing my Algebra 2 notes, but here they are, the 7 rules themselves. Write those down. We're going to work to memorize the heck out of them.
Sure.
And I will be asking you to repeat them back to me. That's the fun part, right? The 7 rules of factoring, it's like a whole chant, okay? The first rule of factoring is, we don't talk about factoring. The second rule of factoring is, don't talk about factoring. Okay? If any of you have seen the movie Fight Club, this is a reference to that. You don't talk about Fight Club, okay? So just keep it between us, okay? Okay, it's kind of an old film by now, but it's a meme. I try to put some jokes into here. If you don't get it, it's okay. You're going to write them down, yes, because that's part of what makes it fun. And when it's fun, it helps your brain remember it. But as far as the actual functioning process in the problem solving, no, you won't use those. Okay. So the third rule of factoring, and the one you will actually start with when attempting problems, is GCF. Okay? The most important step. Always, always, always start with finding a GCF. Can anyone tell me what GCF stands for? Greatest common factor. The greatest common factor. And if we're going to be chanting out these rules, this is a nice abbreviated one. You can get really punchy with it. Okay? Pretend you're at a football game. GCF. Okay. Fourth rule of factoring is special products. And we will look on my day 2 notes, which we will actually see here in a few minutes, the specific special products to be looking for, because these are the shortcuts. These are, if you notice it fits this special form, boom, I can jump straight to the answer, easy peasy. So always check for those before going any further. Number 5, grouping. This is when you notice, hey, this thing is a little bit bigger than I really want to deal with. I don't have a GCF in the whole thing, but maybe there's a GCF from this half and a GCF on this half, and we can group things together to make our lives easier. So always do that next. Number 5 is grouping. And then number 6, the tried and true method, the guaranteed to work every time T-chart method of factoring is where you construct a T-chart where you list all of the potential combinations, all the factors of A times C, and then you see what do those all add to. If I make this one positive and that one negative, it adds up to this, and you try to find a combination that adds up to your B term. This, of course, strictly applies to a quadratic trinomial. We'll talk about how to extrapolate into high-order polynomials at a later date. Right? Just the basics here. T-chart. And when you get really good at the T-chart method, it sometimes transitions into more of a, what we sometimes call the FBI method, the factor by inspection. Okay? You start running these numbers a lot, you will notice, be like, Okay, I can just see that has to be 2 and 12 together, right? And you don't even need to make your t-chart. You don't need to write down all the possibilities because you'll check them all in your brain. And you just inspect it and be like, yep, it has to be these numbers, done. And then finally, rule number 7. I don't have enough fingers. Rule 7, GCF again. If you found the actual greatest possible factor at step 3, there shouldn't be another one at the end. Shouldn't be. But sometimes you're in a hurry, you rush through, you don't find the greatest common factor, you just find a common factor, and then you get to the end, you're like, oh shoot, all these numbers are even. Oh, I could have pulled out another 2. Let me do that again real quick. Okay? So always double check again, is there a new factor that has revealed itself now that you've changed some numbers around that you can factor out again? Yeah. Okay. Any questions at this point? Well, thank you. All right, so I'll run through a few examples here to exemplify. All right. Always check for that greatest common factor first. Right? So when you're looking here, check for the numbers, the coefficients. Look at those. Hey, are those all divisible by something? Yes, they are. I can pull out a 3 from each of those. Let me write that down. Then go to the variables. Is there a variable in common with all of the terms? This is the bit that will save you a lot of time, right? This is the part that lets us tackle these higher order polynomials and reduce them down into something more manageable, is when we can factor out one of the variables from everything. Because this was a cubic, right? And this was a cubic in 2 different variables. Oh, goodness. But they actually had an x in common. In fact, remember that x cubed means x times x times x. And you can factor out as many as they both have. They both have 2 of them. So I can factor out the x squared in front there.
Oh, so factoring, so you can take out x squared, which is all that have in common.
Right, right.
I forgot what factoring.
This drops down to a linear term. This drops down to a linear term, right? All of this is now much easier to deal with any single factor at a time. Okay? All right. I'll get to the special products afterwards. That's on the other page here. But grouping. Right? Anytime you see 1, 2, 3, 4 or more terms, grouping is probably a good idea. Because I can't treat 4 terms like I can with 3. 3 is great, right?
Grouping is the opposite of the
Factoring is the opposite of the distributive property. This whole process is anti-distributing, yes. So as useful as distributing was back in the day, most of the time from this point on, you're going to be doing the opposite. It is usually more advantageous to have your equations and your functions in factored form than in standard form. Why they don't just call that one the standard and use it all the time, I don't know. I blame some old stiff guys back in the day. Those jerks. Name and everything. Anyways, right? So you see how we've got 4 terms here. I don't have a GCF in all of them, mostly because I've got a constant here. Like, oh, everything had an A except that last one. Darn it. And like these 2, they're both divisible by 3, but the 4 isn't. So it really gets in my way. But if you treat them as 2 groups independently, say, hey, what if I factor an A squared out of the first half, and I factor a 3 out of the second half, notice what happens at the end. I get A minus 4 on both sides, which means now this is a binomial. Everything here is one term. Everything here is another term. They are added together. And from this binomial, a minus 4 is a GCF.
Oh, yeah, wait, all we've done this before, right? And then
Almost.
A2 plus 3, yeah. That's like doing it on that one sheet together.
Right. And this is where the coolmath.com, they love to say, hey, stuff in parentheses, call that stuff. Right? You've got to be able to start recognizing, anytime I put things in parentheses, I can now treat it as one object. So this is as if it was a squared times x plus 3x. Oh, now I can factor out the x. Right? And you write that in front, x times, what's left? A squared plus 3. Right? It's all coming back to you now. Okay. Okay, then. The final technique, right? The absolute last resort is to go to that T-chart method. Or, as I said, when you get really good, you don't even have to write down the T-chart. And then we start calling it FBI, factor by inspection. You've got to get things into standard form first. So write down at least this bit in purple. Get it in standard form. You're finding the factors of A times C that add to B. Factors of AC that add to B. And it is kind of fun. It's kind of a little puzzle, a little challenge, like a word search, doing on a number hunt. Yeah, it's very satisfying, right? Because you have this immediate check of, does it work or not? If they both add up to B, you've found it, you're done. Congratulations. Now, when you do this, and you create your chart on the side, right? I was based on this example here. We need two numbers. That product is A is 5, C is 6. So they have to multiply to 30 and add up to negative 13. So I started making a list here, right? So, oh, is it 5 times 6? No, that adds up to 11. Is it 2 times 15? No, that adds to 17. Is it 10 times 3? Yes. If I make them both negative, they'll multiply to a positive number, but add to a negative number. That works. Those are my numbers. Right. And then when you go on from there, you have, I like to call either easy mode or hard mode. If A was 1, you're in easy mode. Because as soon as you have your numbers, look at this. A is 1 times 10 is 10. Factors of 10 that add to 7. That'd be 2 and 5, right? You take those two numbers, the ones that worked for you, your magic numbers, and you can immediately put them in your answer format. When A is 1, those two magic numbers go directly in parentheses, x plus one number times x plus the other number.
A is x, right?
A is 1.
Yeah.
There's an invisible 1 here, right?
Like these are easy ones, but like the hard ones is when we have to.
Right.
And that, oh, I hate that.
Right. It gets harder when A is not 1. If A is not 1, then those two numbers I found, they do not slot immediately into the answer. What you have to do there is like in the example up here. Right? You take those two numbers, negative 10 and negative 3, and you rewrite the B term as two separate terms. Okay? We're going to split that B term in two. And now I have how many terms? 4. What technique do I use for 4 terms? Grouping. Stick some parentheses around them. Boom, boom. 2 sides. And now what can I factor from here? 5x. What can I factor from here? Just a 3. Do I get the same result on both of them? Yes, I do. If you don't, this is another check your work step. If you don't get the same thing here and here, you've done something wrong. Go back. Try again. Because otherwise, this is your GCF. Now, you can factor that out. And the leftovers is one factor. That GCF term is the other factor. And that's not actually too bad. But it's definitely more work than when you get to just do this. This is lovely. I love these. A equals 1 FBIs. You can just look at it and be like, 2 and 5, done, boom.
That actually feels so much better. Like, you get it, it's just like, thank God.
Yes.
Please give
It
me
is.
like all of those the next time.
And then rest easy? Okay. There will definitely be some just straight up, here, factor these things on the next test. We'll throw those in there. Maybe that'll be the multiple choice section. Just run through those. All right. Questions from those bits? Okay. Then I'm going to switch to day 2. Right? Algebra 2 class, they had to do this on 2 separate days. You get it all in one. Here we go. Reminder again. The 7 rules of factoring are very good, very good. Okay, so those special products, right? You either see them or you don't. If you don't see them, you're going to drop down to probably not a grouping because they're usually 2 or 3 terms. You're going to go into T-chart mode, and you'll go through, and you'll do it the long way, and it'll work, and it'll be fine. But if you can spot these guys, take advantage of it because it's way faster. So here are the 1, 2, 3, 4, 5 most common special product forms. The top 3, by far the most common. Very rarely do we use, I'm sorry, not the top 3. How did they sort this? Oh, by binomials versus trinomials. I would say the difference of squares, number 1 most common. Got to know that guy. And the perfect square trinomials are the 2nd most common. These are pretty simple, easy to commit to memory. Sums and differences of cubes is much more complex. I haven't tried to memorize those. I never did. I've tried now that I've been teaching it. But it doesn't come up often enough to really be worth it. Okay? It's a little tough. There's a lot more fiddly bits and places to get it wrong. So I don't try that one. But difference of squares, easy enough. If you can square root a thing, and it's subtracted and square roots the other thing, it will always, always, always split off and be 2 factors, each with that square root number. One is added them, and one subtracts them. It turns into a sum times the difference of those square roots. So this is why it becomes extra important, not just to know your multiplication table, but to know very much that main diagonal, all the square numbers. Immediately recognize, right, 4, 9, 16, 25, 36, that whole line. And immediately spot those and say, hey, I can square root that perfectly. It might be a difference of squares. Similarly, the perfect square trinomials are very close. They are these square sandwiches because they have the squares on both ends, and then there's some extra meat in the middle. Specifically, this is like you go to Subway and you pay the extra $1.50. No, I think $1.50 is what, for extra cheese? It's like $2 more for double meat, right? But you go for it, right? You get the best sandwich possible. Square sandwich, double meat in the middle. Okay? That's how you know you have your perfect square trinomial. I always test this. Can I square root the first term? If it's just like something like an x squared, yes, you can. 4x squared, you can do that, right? It's got one of those perfect square coefficients. Can I square root the last term? Is this, say, plus 9 or plus 16 on the end? Right? And you can. Do so. Find out what that is. What is the square root of the first term? What is the square root of the second term? And then you have to check. Do I have twice the product of those two in the middle? Does this fit as 2ab? Right? I'll go through an example. Don't worry. Because if so, then it gets really simple, because it's now just the sum or the difference of those things all squared. How do I know which sign to use? It's the same one that was on the middle term. If it was plus 2ab, it's plus. If it was minus 2ab, it's minus. Ones that are next to what? Mm-hmm.
What do you want? Where did that 2 go? The 2 in the middle?
Where did the 2 go?
What?
Well, try this backwards. What happens if you were to distribute that?
You get a squared. No, you get a squared minus b, and you get a plus. What they both minus?
You get a times a squared. You get negative b times negative b is positive b squared, right? And I have an a times negative b and a negative b times a, don't I?
Yeah.
Well, b times a is the same as a times b, right? I can switch the order, yes?
They're the same thing. Yeah.
So minus ab, isn't that minus 2ab? Yes?
But let's say I had 2. Wait. But let's say I had CB minus.
Let's look at an example.
What if I had CB minus BC? Then it'd just be 2 negative 2 BC. Whatever number that switched them to that. What if the middle number was like 10?
Then it might not work, right? We're looking at this, right? This is a thing to look for. Check if it fits this format, because then you can shortcut to this answer. If it's not this format, right, if it's any other number, then you have to go T-chart, right?
Oh, wait, this is just to find.
This is the special shortcuts. Just the special shortcuts, right?
That's what you're saying you didn't memorize. You originally had to do.
But no, the ones I didn't memorize is the sum and difference of cubes.
Oh.
These ones I've highlighted in yellow, absolutely worth memorizing.
The ones that are above, really?
These ones here with the cubes, look, you've got this term that comes out pretty nicely, and then you've got this thing that is almost like one of these, but the signs switch around and it's a little more complicated.
Basically, you have this, right? You said a minus b
Uh-huh.
minus b, and that's because they're squared, right?
Right, that's what the square means.
But why isn't it a minus b right here? It's like a plus b and a minus b.
What happens when you multiply those out? What is a times a?
Right.
What is a times negative b?
Negative ab.
What is b times a?
Yeah. No.
ba, but we can write it as ab, right? And then b times negative b?
Negative b squared.
Combine like terms. What happens to these guys?
They eliminate.
Yeah. So what are you left with?
But then, like here, it didn't matter then?
These down here, they don't eliminate. Correct. When you have matching signs, they will multiply, you will get twice the middle. If you have alternating signs, they will eliminate and you get no middle.
Let me just say hi to you. Hey, what's up, y'all?
All right. Good? No, that's good. Asking questions is awesome.
I am actually trying to learn. I don't know if you know this. Okay, difference of 2 squared. Oh my god, I have
Yeah.
a problem.
Should we
Let's do it.
see? These are all difference of 2 squares. That's too easy. Do I have an example of the trinomial?
Let's do it. We don't know this.
We don't need to. You've got the work. Okay, you can either spend your time on these or you can go to the worksheet for today.
Not yet. Let's do number 3. Just number 3 only.
All right, number 3.
So let's go speed run.
What is it then?
11, so it's x, 11x minus,
What, 11x?
11 minus 11, x minus 11, right? And then parentheses, and then x plus 11. And we're done, right? We're done.
Yeah,
Let's go.
that's it.
Let's do homework.
That's difference of squares.
Oh, okay, I get it then. That was dumb.
You learned that.
You've probably seen this like at least 3 times now. Would be my guess, in one form or another. This is my form of it. I use the 7 rules of factoring. Okay?
So you're sitting there, you have a problem, and you're like, all right, let's not talk about factoring. And you're like, let's not talk about factoring. And then you're like, all right, let's run here.
Yeah. Run through these in order. Now, yes, the first 2 are just for fun. They are not practical. You can skip them on the test, right? But if that's fine. You say that to yourself twice, and that gets you running on the list, that works. All right, any other questions? No? Okay, then you have a worksheet. Now, the worksheet I put up there on Google Classroom is the same worksheet we will use all week. Today, we're just doing page 1, which actually has its own summary of the factoring techniques at the top, and then I think 9 exercises at the bottom of the page. That's it. That's all I need from you today, just those 9. The 9 problems at the bottom of the first page of the worksheet on Google Classroom. All right.
Last page, right? The first 4.
For you? Sure. Yeah. All right. For the rest of you, read the instructions. RTFD. Read the fantastic directions.
Read the freaking directions.
There you go. All right. I think I'm going to call the stream here.